According to the National Electrical Code, or NEC, GFCI protection is required for outdoor receptacles that meet certain criteria. These criteria include being within 6 feet of water or being not readily accessible. The height of the receptacle is not a factor in determining the need for GFCI protection. Also, the fact that the receptacle is on a covered patio does not automatically exempt it from GFCI protection. The key consideration is whether it is within 6 feet of water. The NEC defines readily accessible as capable of being reached quickly for operation, renewal, or inspections without requiring those to climb over or remove obstacles or to resort to portable ladders or chairs. Since the receptacle in question is on a covered patio and is not readily accessible because it is 8 feet high, GFCI protection is not required. However, it is important to consider additional factors. Firstly, the heater should be properly grounded for safety. Secondly, the cord and plug should be in good condition and free from damage. Thirdly, the heater should be used in accordance with the manufacturer's instructions. Let's delve into the details of GFCI protection as it pertains to electrical receptacles and equipment, particularly focusing on the requirements outlined in the National Electrical Code, or NEC. A GFCI, or ground fault circuit interrupter, is a safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing in a circuit and quickly interrupting the power if it detects a ground fault, which is an unintended path of current to ground. This rapid interruption prevents electricity from flowing through a person who might be in contact with a live conductor and a grounded surface, thus preventing serious injury or death. The NEC mandates GFCI protection in various locations and for specific types of equipment to enhance electrical safety. One of the primary areas where GFCI protection is required is in wet or damp locations. This is because water significantly increases the risk of electrical shock, and GFCI devices are highly effective at mitigating this risk. Specifically, the NEC requires GFCI protection for 125-volt, 15 amps and 20 amps receptacles installed in bathrooms, garages, and outdoors. These locations are considered to be more prone to moisture and accidental contact with water, making GFCI protection essential. When considering outdoor receptacles, the NEC takes a stringent approach to safety. All 125-volt, 15 amps and 20 amps receptacles that are readily accessible and located outdoors must have GFCI protection. Readily accessible means that the receptacle can be reached without having to climb over obstacles or use tools like ladders or chairs. This requirement ensures that anyone using outdoor electrical equipment, such as power tools or extension cords, is protected from ground faults. GFCI protection is also required for receptacles within 6 feet of any water source, such as sinks or pools. This zone is considered particularly hazardous due to the increased risk of electrical shock in proximity to water. Even if a receptacle is not directly exposed to water, its proximity to a water source necessitates GFCI protection to safeguard against potential ground faults. In addition to receptacles, certain types of equipment also require GFCI protection. For example, electric ranges and clothes dryers that are cord and plug connected must have GFCI protection if they are installed in a location where such protection is required for receptacles. This ensures that these high-voltage appliances, which are often used in damp or wet environments, are operated safely. The NEC also addresses GFCI protection for specific applications such as swimming pools, spas, and hot tubs. These areas pose a significant risk of electrical shock due to the combination of water and electrical equipment. Therefore, the code mandates comprehensive GFCI protection for all electrical components associated with these installations, including pumps, heaters, and lighting fixtures. This stringent requirement helps to minimize the risk of electrical accidents in these recreational environments. When evaluating whether a particular receptacle or piece of equipment requires GFCI protection, it is essential to consult the latest edition of the NEC. The code is updated regularly to incorporate new safety standards and technological advancement. Understanding the specific requirements and exceptions outlined in the NEC is crucial for ensuring compliance and preventing electrical hazards. In the situation described, the question revolves around whether a GFCI circuit breaker is required for a 208-volt cord and plug connected heater located on a covered patio, with the receptacle set at 8 feet. The patio is part of a bar and grill establishment, and the heater is a quartz tube heater. The circuit is a 2-pole 20-amp circuit. The answer hinges on several key factors. Firstly, the NEC requires GFCI protection for outdoor receptacles that are within 6 feet of water or are not readily accessible. Secondly, the height of the receptacle is not a determining factor in the need for GFCI protection. Thirdly, the fact that the receptacle is on a covered patio does not automatically exempt it from GFCI protection. The primary consideration is whether it is within 6 feet of water. Fourthly, the NEC defines readily accessible as capable of being reached quickly for operation, renewal, or inspections without requiring those to climb over or remove obstacles or to resort to portable ladders or chairs. Given that the receptacle is located on a covered patio and is not readily accessible due to its height of 8 feet, GFCI protection is generally not required. However, additional considerations should be taken into account. The heater should be properly grounded for safety. The cord and plug should be in good condition and free from damage. The heater should be used in accordance with the manufacturer's instructions. It's also crucial to verify whether there are any local codes or regulations that may impose stricter requirements than the NEC. Local jurisdictions may have specific amendments or additions to the NEC that mandate GFCI protection in situations where the national code does not. To summarize, while the NEC does not typically require GFCI protection for receptacles that are not readily accessible, it is essential to ensure that all other safety measures are in place and that the installation complies with all applicable codes and regulations. Grounding the heater, maintaining the cord and plug, and following the manufacturer's instructions are all critical steps in ensuring safe operation. Let's consider the National Electrical Code specific requirements and interpretations for GFCI protection in various scenarios. Firstly, let's examine the 6-foot rule. The NEC mandates GFCI protection for all 125-volt, 15 amps and 20 amps receptacles located within 6 feet of any water source. This includes sinks, pools, hot tubs, and even damp locations where water may accumulate. The purpose of this rule is to prevent electrical shock in environments where the risk of contact with water is high. The 6-foot distance is measured horizontally from the water source to the receptacle. Secondly, accessibility is also a factor. The NEC requires GFCI protection for all 125-volt, 15 amps and 20 amps receptacles that are readily accessible and located outdoors. Readily accessible means that the receptacle can be reached without having to climb over obstacles or use tools like ladders or chairs. This requirement ensures that anyone using outdoor electrical equipment is protected from ground faults. Receptacles that are located high up or behind obstructions are generally considered not readily accessible. Thirdly, equipment grounding is always critical. Proper grounding is essential for electrical safety, regardless of whether GFCI protection is required. Grounding provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker and prevent electrical shock. All electrical equipment, including heaters, should be properly grounded in accordance with the NEC. Fourthly, cord and plug maintenance is also important. The cord and plug connecting the heater to the receptacle should be in good condition and free from damage. Damaged cords and plugs can create a shock hazard and should be replaced immediately. Regular inspection of cords and plugs is essential for maintaining electrical safety. Fifthly, manufacturer instructions should always be followed. The heater should be used in accordance with the manufacturer's instructions. These instructions provide important safety information and guidance on proper installation and operation. Failure to follow the manufacturer's instructions can result in electrical hazards or equipment damage. Sixthly, local codes and regulations must be considered. Local jurisdictions may have specific amendments or additions to the NEC that mandate GFCI protection in situations where the national code does not. It is important to check with the local electrical inspector to ensure compliance with all applicable codes and regulations. Let's examine some practical examples to illustrate the application of these rules. Firstly, consider a receptacle located on a covered patio 8 feet high and within 6 feet of a sink. In this case, GFCI protection would be required because the receptacle is within 6 feet of a water source, regardless of its height or the fact that it is on a covered patio. Secondly, consider a receptacle located on a covered patio 8 feet high and not within 6 feet of any water source. In this case, GFCI protection would not be required because the receptacle is not readily accessible due to its height and is not within 6 feet of a water source. Thirdly, consider a receptacle located outdoors, readily accessible, and not within 6 feet of any water source. In this case, GFCI protection would be required because the receptacle is readily accessible and located outdoors. Fourthly, consider a receptacle located indoors, not within 6 feet of any water source, and not readily accessible. In this case, GFCI protection would not be required because the receptacle is located indoors and is not within 6 feet of a water source. Let's delve deeper into the concept of readily accessible as it relates to GFCI protection. The NEC defines readily accessible as capable of being reached quickly for operation, renewal, or inspections without requiring those to climb over or remove obstacles or to resort to portable ladders or chairs. This definition implies that a receptacle is considered readily accessible if it can be reached by a person of average height without any special tools or equipment. Receptacles that are located high up, behind furniture, or in locked enclosures are generally considered not readily accessible. The intent of the readily accessible requirement is to ensure that GFCI protection is provided for receptacles that are likely to be used by the general public. Receptacles that are not readily accessible are typically used for specific purposes and are not intended for general use. Let's consider some specific scenarios to illustrate the application of the readily accessible rule. Firstly, consider a receptacle located on a wall 4 feet above the floor. This receptacle would generally be considered readily accessible because it can be reached by a person of average height without any special tools or equipment. Secondly, consider a receptacle located on a ceiling 10 feet above the floor. This receptacle would generally be considered not readily accessible because it would require the use of a ladder or other equipment to reach it. Thirdly, consider a receptacle located behind a large piece of furniture. This receptacle would generally be considered not readily accessible because the furniture would need to be moved to access it. Fourthly, consider a receptacle located in a locked enclosure. This receptacle would generally be considered not readily accessible because a key or other tool would be required to open the enclosure and access it. Let's consider the implications of not requiring GFCI protection for receptacles that are not readily accessible. In these cases, other safety measures should be implemented to protect against electrical shock. These measures may include using properly grounded equipment, inspecting cords and plugs regularly, and following the manufacturer's instructions. It is also important to educate users about the potential hazards of electricity and how to avoid electrical shock. Let's delve further into the importance of grounding and bonding in electrical systems. Grounding and bonding are essential for electrical safety because they provide a low impedance path for fault current to return to the source. This helps to trip the circuit breaker and prevent electrical shock. Grounding refers to connecting the electrical system to the earth. This provides a reference point for voltage and helps to stabilize the system. Bonding refers to connecting all metal parts of the electrical system together. This ensures that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. The NEC requires that all electrical equipment be properly grounded and bonded. This includes receptacles, lighting fixtures, and appliances. The grounding and bonding system should be inspected regularly to ensure that it is in good condition. Let's consider some specific examples of grounding and bonding. Firstly, consider a receptacle. The receptacle should be grounded to the metal box that it is mounted in. The metal box should be grounded to the grounding electrode system. Secondly, consider a lighting fixture. The lighting fixture should be grounded to the metal box that it is mounted in. The metal box should be grounded to the grounding electrode system. Thirdly, consider an appliance. The appliance should be grounded to the grounding electrode system. The grounding electrode system consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the electrode to the electrical system. The grounding electrode system should be installed in accordance with the NEC. Let's discuss the importance of regular inspection and maintenance of electrical systems. Regular inspection and maintenance are essential for ensuring the safety and reliability of electrical systems. Electrical systems should be inspected regularly by a qualified electrician. The inspection should include checking for damaged wiring, loose connections, and other potential hazards. Any problems that are found should be repaired immediately. Electrical systems should also be maintained regularly. This includes cleaning equipment, tightening connections, and replacing worn parts. Regular maintenance can help to prevent electrical problems and extend the life of the equipment. Let's consider some specific examples of inspection and maintenance. Firstly, consider a receptacle. The receptacle should be inspected for damage, loose connections, and proper grounding. Secondly, consider a lighting fixture. The lighting fixture should be inspected for damage, loose connections, and proper grounding. Thirdly, consider an appliance. The appliance should be inspected for damage, worn cords, and proper grounding. Let's consider the role of qualified electricians in ensuring electrical safety. Qualified electricians are trained and experienced in electrical work. They are familiar with the NEC and other applicable codes and regulations. Qualified electricians can perform electrical installations, repairs, and inspections safely and effectively. It is important to hire a qualified electrician for all electrical work. This will help to ensure that the work is done properly and that the electrical system is safe. In summary, GFCI protection is a critical safety measure that helps to prevent electrical shock. The NEC mandates GFCI protection in various locations and for specific types of equipment. When evaluating whether a particular receptacle or piece of equipment requires GFCI protection, it is essential to consult the latest edition of the NEC and to consider all applicable codes and regulations. In addition to GFCI protection, proper grounding, bonding, and regular inspection and maintenance are also essential for electrical safety. By following these guidelines, you can help to ensure the safety and reliability of your electrical system. Always consult with a qualified electrician for any electrical work.